All right. Okay, so we're going to be dealing with parallel lines and perpendicular lines in 3.3. So let's first focus in on parallel lines. So if we have a set of parallel lines, they will have the same slope, which makes sense, right? Parallel lines never intersect. So wouldn't they need to rise over run equally so that they would never intersect? So that's something to note. So notice I have the red line, y equals 2x plus 5, and I have the blue line, y equals 2x minus 3. The slope is the same. It is both 2, 2, 2. So by definition, they have to be parallel. Everybody good with that? Okay. Okay, so it says all the lines parallel. Well, I would always, in this case, get it into y equals mx plus b form so you can compare the slopes. So let's take that top one. So the first thing we would do is subtract 4x. So I have y is equal to, I'm going to write the 4x part first. So that'd be negative 4x plus 8. Let's do this one. So the first thing I would do is subtract 6x. So then I have 2y is equal to negative 6x plus 12. Divide by 2. So y is equal to, divide both of these by 2, so that would be negative 3x plus 6. All right, we're comparing the slopes. One of the slope is negative 4, one's negative 3. Parallel, yes or no? No, they will at some point intersect because they're not the exact same slope. So no. Not parallel lines. Okay. Good job. Okay, let's go to perpendicular lines. So perpendicular lines are perpendicular if they have opposite reciprocal slopes. Now perpendicular means that they cross, they intersect at a 90-degree angle, and this will always happen if the slopes are opposite sign, so one's positive, one's negative, which makes sense. Look, isn't the red line positive? For it to intersect, wouldn't the other one need to be negative, guys? So they're opposite and then reciprocal. Reciprocal means flipped, the fraction is flipped. So notice the red has a 3x, and then the blue has a negative, it's the opposite sign, and then the reciprocal slope, because this is the same thing as 3 over 1. Opposite reciprocal makes them perpendicular lines, which will intersect at a 90-degree angle. You have that written down for yourself? Okay. Okay, so all the lines perpendicular. This one's already in y equals mx plus b. So is the set of lines perpendicular, yes or no? Yes, they are opposite reciprocal slopes, yes. Okay, with this one, we would need to get it into y equals mx plus b, subtract 4x. So we have negative y is equal to negative 4x plus 3, divide by negative 1. So y is equal to positive 4x minus 3. Let's do this one. So we would subtract x. Negative 4y is equal to negative x plus 2, divide by negative 4. So that would be y is equal to, isn't a negative divided by a negative a positive? So let's write that as 1/4 x. And then 2 divided by 4 isn't 2, it is, so minus 1/2. Okay, let's look at our slopes. Are they reciprocals? Yes, are they opposites? No, so these are not perpendicular. They'll intersect at some point, but it doesn't mean they'll intersect at that 90-degree angle. Does that make sense, everyone? Okay. We know they're not parallel, so they will intersect, but not at that perpendicular angle. Okay, so right here it says determine the slope of a line that is parallel and perpendicular to the line that has a slope of negative 5, 6. So what would be the parallel? What would be the parallel slope? Negative 5, 6, right, everybody? What would be the perpendicular? You said what? 6 divided by 5. Good, 6/5, right? Opposite sign, reciprocal. Pretty easy stuff, right? As long as you know what you're doing. Okay. Okay, it says, are the given equations parallel or are they perpendicular? Do we really need to go through it, or would you know what to do? You'd get it into y equals mx plus b form, compare the slopes, right, everybody? If they're the same, parallel. If they're opposite, reciprocal, perpendicular. So you could say it is not parallel, it is not perpendicular, because it could be neither. That makes sense, right? Okay, great. Okay, so let's read this. Oh, there's a little typo there, but that's okay. It says 2 points on the line 1 and line 2 are given. Plot the points and then determine the slope of each. Are they parallel, perpendicular, or neither? So I'm going to graph line 1. We're going over 1 up 1, and then over 4 up 1, 2, 3. It wants us to graph that, so let's stay pretty accurate. The slope is rise 2, run 1, 2, 3. So this one had a slope of rise 2 over 3, must be going up. Rise 1, 2 over 1, 2, 3, down 1, 2 over 1, 2, 3, down 1, 2 over 1, 2, 3, down 1, 2 over 1, 2, 3. Okay, I have line 1. Okay, let's do line 2. So we're plotting the points -1 up 3 units. Then we're going over 3 down 1, 2, 3 units. So let's see what our rise over run is. So we're going down 1, 2, 3, 4, 5, 6. Down 6, and isn't it negative? Look, from left to right, isn't it negative facing? So I'm writing -6. And then, let's go back here, down 6 over 1, 2, 3, 4. So let's simplify that. What is it technically? -3/2. So we're going down 3, down 1, 2, 3 over 1, 2, down 1, 2, 3 over 1, 2, 1, 2, 3 over 1, 2. And then up 1, 2, 3 over 1, 2. Okay, there's our line 2. It's hard for me to draw it when it's so big. Okay, look at the slopes. I've written them down. Aren't they opposite reciprocal? So they're perpendicular. Okay, very good. Okay, so it says right here, find the equation of line L. Express your answer in slope-intercept form. So everybody, we have 2 line L's, red line L, purple line L. And we are given the equation of blue line. Everybody see? So let's look at our purple line here. We're told it is, let's pretend like we were told, you would be told it is perpendicular. So we can automatically say, or else they would write a little 90-degree angle thing there. Okay, so if it's perpendicular, what would be the slope? 2, right? 2x. And then what's our y-intercept of purple? 4. Positive 4. Does everybody see how we did that pretty quick? And then we're told that red line is parallel, and if that's true, what would the slope need to be? -1/2 x, and then what's the y-intercept? -1, good, -1. So pretty easy stuff. Okay, great. Okay, let's read this. So I would maybe write this example down. It says, find an equation of a line with the given properties. So this is 32 out of the book if you're interested. So it says they want a line that's parallel to y equals -3x plus 1 that passes through the points 2, 5. So really, the only thing that matters to us is the fact that it's parallel. And so the only thing that matters to us is we know that y equals mx plus b is our line, and we know that y equals, if it's parallel, won't m be -3? -3x plus b. Everybody? Since it's parallel? And now how can we find our plus b? We've done this before. We did it in the last lesson. That's why it's so intertwined, these 2 lessons. What would I do with my xy point over here? Plug it in. So we'd have 5 is equal to -3 times 2 plus b. So I have 5 is equal to -6 plus b. I'm going to add 6. 11 equals b. So now my final answer is y is equal to -3x plus 11. Okay, pretty similar to our last lesson. Okay, it says write an equation of a line that's perpendicular to this, but that passes through this point. So then what would be our slope on our new line? -1/4 x and then plus b. And now we'll take our xy point and plug it in. So our y value is 1. 1 is equal to -1/4 times by 4 plus b. So 1 is equal to, what is -1/4 times 4? Yep, -1 plus b. So then we'll add 1. 2 equals b. So we'll go back up here. Y is equal to -1/4 x plus 2. How are you guys feeling about this stuff? Good, 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 good. Okay, so I think we get the picture here. I just want to make sure, parallel to this line through this point. Well, what I first need to do, get it into Y equals mx plus b form, go for it, just like we did the last examples. I don't want to waste your time. Okay, great. All right, that's the end. See, it was okay to learn 3.3 today. Okay, the rest of the time is yours. I'm going to write 3.3 problems that I recommend doing to be prepared for the exam. Now, you guys do understand, right, that your responsibility lies within you. Like, on the homework problems, if you felt confident, if you were doing a section and you felt confident and you moved on, then that's fine, right? Like, the homework barely puts anything on your grade. I really just look at your test scores. You know what I mean? Like, if you hand me in homework and I feel like you gave it a valiant effort, you're going to get full points. However, don't be that person that thinks that you can skip problems, because a lot of people that are confident in their abilities actually should have been confident. Does that make sense? So I recommend just doing them all. How come I'm good at math? Because I'm willing to practice math. That really is why I'm good at it. It doesn't come naturally to me. So I just recommend, that's why I assign these, is for practice. I would just do them all, but that's just me. 221, it's on page 221, 3.3, 7, 9, 11, 13. Okay, the rest of the time is yours to do homework. You have actually like 30 minutes of class left.